Hey, Fox here. This video is a little bit different than what I normally do, but we're going ahead with it anyway. Let's start with, what is distributed computing? It's a process by which you take a large amount of data, you break it into smaller chunks, you send those chunks out to less powerful desktop computers, they return the results of processing back to the project that sent those chunks out, and it's typically done over the internet. That's distributed computing, network computing, grid computing, and volunteer computing in a nutshell. The most common way this is done is through the BOINC platform. The BOINC platform is the Berkeley Open Infrastructure for Network Computing project, and it's just one way of distributed computing. It's a common platform. Many different projects use it, and it came about through the SETI at Home program, which we'll go into in a minute. But by generalizing the platform, they basically enabled other projects to become possible, such as projects in chemistry, mathematics, theoretical physics, cosmology, even biological research is done on the BOINC platform. Now, I'm going to show you a few projects. This is the SETI at Home project. SETI at Home is a project that looks for alien life by analyzing data that has been recorded from different telescopes, especially the Arecibo large telescope. This one is the IBM World Community Grid, and it's primarily focused on disease research, especially cancer, AIDS, Zika virus. At one point there was a clean water project on here. And then Einstein at Home, another BOINC project. It looks for different signals that indicate new pulsars using data from different telescopes, especially, look, they use the Arecibo data too. Now, BOINC isn't the only distributed computing platform. There's also distributed.net, which focuses on different numbers, mathematics. In this case, I participate in the RC5 project, which tries to crack a message that has been encoded with RSA-72. There's also the GIMPS project, which is the Great Internet Machine Prime Search project. Looks for the largest prime number it can. There's also the Folding at Home project, which basically folds proteins, trying to find different cures and different treatments, basically. Let's go with that. Now this is the BOINC project manager. As you can see, I participate in several projects. It sends the data for me to process, and my computer processes it while I'm using it, actually. And it doesn't take all that much extra computing power to do. And then it sends the results back to the project server. This is the Folding at Home client. It's very simple. All it does is sits here, does the same thing. I don't run them all at once for resource reasons, but I kind of iterate through them. And where is it? There it is. This is the distributed.net client, which I'm using to I'm kind of trying to find the entire key space for RC572, which is the RSA encryption, trying to crack a message. It's how different encryption algorithms have been broken through the years. And this is the GIMPS client, Prime 95. This one's the one that searches for the largest prime number it possibly can. Now, like I said, BOINC is not the only distributed computing platform. There are others, as I've shown you, but it's the most well-known and utilized, and even the most well-documented that I've seen. If you aren't already a volunteer on a project and you have a computer that's sitting there always on doing nothing, or it's got like light usage, I would strongly recommend that you participate in one of these projects, because no matter how small your contribution is. It is immeasurable to the advancement of human knowledge, especially in mathematics, sciences. I mean, you can even find ET. I mean, come on. I would recommend checking out the links in the description. I hope you find a cause that you're passionate about or interested in, and I will, of course, make a couple of more videos about this later, but go ahead and check out those links. Thanks for watching, and go compute for science.